Hi everyone. This is going to be my first lecture online. Uh, okay, I will try the best I can. Last time we have studied thin lenses. Remember the definition: thin lenses is the very thin, the size, this size from one end to another end. The thickness much smaller compared to the object distance and image distance. And we have a converging lens which is going to bring a parallel light beam to focal point, and the converging lens will give you either real image or virtual image. Now second one we call diverging lens or concave lens. This one going to spread out a parallel light beam. uh, so seems like you have a focal point from another side. The light beam originates from the focal point, and this we call virtual focal point. Uh, Please recall what we did in the lab, the two lenses. So now we're going to work lens equation. There are two important ones. Okay, we start from here. This is the lens. Okay, here's the object. This distance we call object distance P. And then we assume the image from another side. So now this is the image. Okay, this distance from the center of lens to image we call Q, the image distance. Now the focal point. Uh, the focal point is supposed to be both sides, depends which side we need. The distance from focal point to the center of lens we call focal length. Okay, so we work the first equation. We proved the magnification definition is the image height over object height. We use capital M equals negative Q over P. The image distance over object distance. Don't forget the negative sign. It's very important. So that's first important equation. Now we work second one. So now we look at this angle. Uh, Again, h and h prime are the height of object and height of image. Okay, now we look at this angle, theta, this angle. Uh, so now the tangent of theta equals this height, which is h, over this distance, which is f, right? So we have a tangent of theta equals h over f. This height of the object over focal length. Now we look this side. This angle of course equals that angle, so also the theta. Tangent of this theta equals this height h prime over that distance, which equals q minus f. This is q, this is f, and this distance equals q over f. And don't forget that this h prime is negative because it's upside down. We call inverted. So tangent theta equals h over f, and also equals negative h prime over q minus f. So now we will work some math. For example, we divide by h both sides, then we times q minus f both sides, so we're going to have this. Okay, so now uh, remember from the last one here, we already have the conclusion. H prime over h equals negative q over p. We're going to use that here. Okay, so then we have this one. So we're going to use the q over p, replace negative of h prime over h. So we have this q over p equals Q minus F over F. So now we only have the focal length, uh, object distance, and image distance. Okay, now what we do? We cross multiply. So we're going to have F times Q equals P times these two. So it's P times Q minus P times F. Okay, we almost get there. So now, if both sides we times 1 over QPF, or we could say both sides divided by QPF. Uh, so this side divided by QPF will give you 1 over P. This divided by QPF will give you 1 over F. Then this term divided by QPF will give you 1 over Q. Okay, then we have this result. 1 over F equals 1 over P plus 1 over Q. This is very, very important equation. We call length equation. Okay, so the negative sign because we move the 1 over F to one side and PQ another side. So this is the equation we're going to use solve our problem. Okay, so now when we solve problem here, so very important, we call sign convention for lenses. Okay, so now P. So if the object is front of lens or the left side of lens is positive, we always keep the object on the left side, unless we have a two lens system. We're going to discuss that later. So now, if the object back of the lens, we take negative sign, the right side of lens. Okay, now the Q. If Q is back of the lens, means the right side of lens is real image. Okay, so now if the image is front of lens, we call virtual image. Well, we have to discuss problem before we can understand better. So now the H prime, this is the height of the image. So if the image is upright, so we call a positive. Okay, if image is inverted, upside down, it's negative. H will take negative sign. Okay, then here's very important. For converging lens, F, the focal length is always positive. Diverging lens, the F always negative. Very important. So now we're going to do two different ways. First, we're going to draw the what we call the real diagram. Use straight line. See what's going to happen. So we're going to have one lab when doing this. Okay. So now here's how we draw the ray diagram. The first ray is drawn parallel to the first principal axis, and then pass through one of the focal lengths. The second ray is drawn through the center of length and continue in straight line. Okay, so we just stop right here. We don't have to use a third one. Look here. So suppose here's the length. Here's the object. Suppose the object distance given, and also the focal length given. Let's say the focal length equals 10 centimeter, the object length equals 20. Okay, so now we're going to draw a ray diagram. The first one should be parallel to the principal axis. This axis, a path center we call principal axis. And then here's front, and here's the back of the lens, or you call left and right. So now the first ray starts from the object, parallel to the principal, come to here, then after there, going to pass the focal point. Now the second ray going to go straight through the center of the lens, and this one will not change direction. We assume because we assume it's a thin lens, very small, sides. So now, if you can draw the third one. Okay, from the left side of front, you pass a focal point, come to lens. Then what happens? Going to be parallel to the principal axis. So now the three rays, one, two, three, gonna meet each other at the back of the lens. Give you the image. See? So this image may be upright, may be inverted like this situation, may be bigger or smaller, or even formed on that side. I will discuss that. Okay, so now let's see what happens. So now we're going to calculate this example in our textbook. Okay, that's example 23.7 in our textbook. So you can read that. So that's very important and very useful. So we're going to study converging lens f equals 10 centimeter. So this is going to be real. I'm sorry, this is converging lens, so f always positive. Okay, so now we of course we can use the ray diagram. One, two past center, and three. And the three are going to meet each other. Okay, so if you use a piece of paper, draw this one. Okay, the first one is the f equal 10 centimeter, and we assume we have the object at 30 centimeter, the front of lens. Okay, so this is 10, this is 30. Then you draw three lines. Okay, then you will find them up. Okay, meet each other at this point. So give you the image. So let's say this image is going to be upside down. We call inverted, and it's reduced. See the object this high, and the image is smaller. It is real because the image, the right side or the back side of the lens. So come this side, we call the image is positive. I'm sorry, the image is real. Okay, so now if you carefully measure distance, you find, okay, image should be 15 centimeter from the lens. Okay, so that means Q is equal to 15. Now let's calculate. This just, draw a line, the ray diagram we call. Okay, now we calculate P equals 30 centimeter, and we want to find Q equals what? And M, magnification equals what? Okay, we use the length equation. Okay, then we plug in the number 1 over F, which equals 10 centimeter, equals 1 over 30. This is the object distance, equals 1 over Q. Okay, so of course we can move this because we want to find the Q. How we move this one to that side? We have 1 over Q equals 1 over 10 minus 1 over 30. So now if you use a calculator, you can do that. 1 over 10 minus 1 over 30. If you try, it will give you 0.0667. I'm going to wait you for 1 minute. Let you finish this. Is that what you got? Great. Okay, now that's 1 over Q, right? So we want to find the Q, so it should be Q equals 1 over this number. So then you find give you 15 centimeter. See? F equals 10 centimeter, P equals 30 centimeter, and Q equals 15, just like this one. Okay, so now we find magnification. The definition is the image height over object height equals negative P over Q. Okay, I'm sorry, Q over P. So Q equals 15 and P equals 30. then give you, don't forget negative sign there. I'll give you negative 0.5. Okay, what this mean? That means magnification equals negative zero point 0.5. The negative tell you what? Inverted, upside down. Zero point 0.5 tell you what? Reduced. Okay, so now overall the image is real because P is positive. It's inverted because negative sign, and reduced because m smaller than 1. Uh, what kind of the lens, the optical system gave you that? Real, inverted, reduced. Well, that's camera. Camera. So now let's go second example. I will give you the rest for your practice. You can open your textbook or go my class notes on Canvas and do the rest. So now second example. So now what is the P equals 15 centimeter? Okay, if P, the object on the left side front equal 15 centimeter, and we want to find the Q and M. Well, the F, of course, still same. So 1 over 10, that's F equals 10, equals 1 over P, 15, plus 1 over Q. Then we do the same thing like this. So now we're going to do a little different. We find the Q directly. Because 1 over Q equals 1 over 10 minus 1 over 15. So Q will equals 1 over that. So 1 divided by 1 over 10 minus 1 over 15. Okay, this you will calculate, so to give you 30 centimeter. You got that? Okay. So now we found the magnification. So the height of the image over height of the object equals negative of the Q over P. Q equals 30 and P equals 15. Negative 30, you will have negative sign here. 30 over 15 gave you negative 2. So now let's say, is this image real or virtual? I will say it's real. Why? Because Q is positive. Because the image distance is positive. Okay, it's inverted because negative sign. It's upside down. Okay, it's enlarged because see the magnification equals 2. That means the image is 2 times of the object, become bigger. Example projector or the movie. Okay, so today we stop right here. I will send you second one very soon. Thank you.